Hi, in this video, we're going to take a look at DHCPv6 prefix delegation. Okay, so in IPv4 world, your home router typically will get a public IPv4 address, a single address, just for its ISP or internet-facing interface. Could be a private address if the ISP has to do carrier grade NAT and it's running out of public IPv4 addresses. It's quite possible your home router might get a private address. That's happening more and more. But in either case, your router will also act as a DHCPv4 server and assign private IPv4 addresses for your internal devices. Of course, this means your router must perform NAT to do the translation between the private addresses and whatever address it received from its ISP. And that's also known as port address translation because it's using a single address typically to translate to multiple private IPv4 addresses. Okay. There is no NAT between private and public in IPv6, which is always a source of debate. But IETF has always stated that, and really the most people in this industry want nothing to do with having to do this NAT. It breaks too many things. There is network address translation in IPv6, but it's between IPv4 and IPv6. It's protocol translation, not address translation. Okay, so the world of IPv6, we want complete end-to-end reachability. That was one of the fundamental principles of the internet, was the end-to-end principle. Any two devices on the internet should be able to reach each other. That's not the case with NAT. You can, but you have to go through a third party to do so, such as Skype. Anyway, so in the world of IPv6, your home network, your business network, whatever, will get its own globally routable IPv6 prefix. No NAT. I didn't say address, I said prefix. That's a whole network. Okay, and IPv6 typically uses, or the ISP will typically use DHCPv6 PD, prefix delegation, for the home or small business to do this. Okay, so the ISP router is known as the delegating router. The home router is known as the requesting router. This is prefix delegation terms. Okay, so first, the home router needs an address on its interface with the ISP. Okay? So that can be attained either using Slack, stateless DHCPv6, which is Slack, or stateful DHCPv6. Okay, but what about the homeland? Okay, the home network. Well, it's going to get its own IPv6 prefix. All right, so let's take a look. First of all, the home router needs an IPv6 address for its interface connected to the ISP. Okay. So it's going to request, and at the same time, it's going to request a prefix for its local area network. Okay. And we're going to see how this works. A subnet prefix will be given to the router to assign to its home devices, and it will then use that to send out a router advertisement with the prefix. We'll see how this works in just a moment. Okay, so first, let's just take this step by step. The router sends out a DHCPv6 PD request saying, hey, I want to initiate prefix delegation with you. And the router will assign a prefix for the requesting router to use. Yeah. Let's see here. I want to kind of go through some of this here, show you. Let me go past it. I want to show you how this actually works. Okay. I shouldn't just go through this, but step 3, the router will, the prefix that it receives, it will send out as a router advertisement. This will make sense here. Let me go over this whole summary, how it works. So notice here that the address, the prefix that that on this link here, the ISP has with the home is this prefix here. So let's say that the router, the ISP router sends out a router advertisement. Okay, the home router can use this information and actually we'll see will assign an address to this interface. Okay. It will also send out prefix delegation information. And this will be a prefix for this network here. Okay. In this case, let's say the home router is getting a /48. Now, what I get at home is a /64. I'll talk about the difference here in a moment. Okay. But if my ISP is sending me a /48 or a /52, it actually allows me to subnet. We'll see how this works here. So let's say that the ISP is saying, hey, you get this whole /48. So I know that I get this whole /48 that I can use for any of my subnets. Okay. Then I will subnet it. So here's the /48 here. And this here will be my subnet. The router will actually do the subnetting. So given this /48, the router can take this information and create its own subnets. All right, and it can send, so we'll send out a router advertisement, in this case saying, I'm going to use the first subnet, and this is the /64 I'll send out. The host will then take this router advertisement and using Slack, create its own interface ID with this as its prefix. Okay. But given a /48, this allows this home router to have 65,536 subnets, each with 18 quintillion devices. Now, it's not about we need that many subnets or we need that many devices. It's just what we don't have to worry about saving addresses or how to conserve addresses and working with these numbers. Just makes it a lot easier to have numbers to work with. That make addressing planning a lot more easy, much easier. Okay, I just want to actually mention a couple of things here before I end this video. Sorry, I took out a couple of slides that got a little bit more detail than we needed. But this interface here, this router is going to receive an address from this prefix. And it's going to either do it via Slack or stateful DHCPv6. Okay, so this router here will send the router advertisement, which is specifically for this interface, this prefix. So first the router will have an interface address here. Then it will go through the prefix delegation process and get a prefix that is specific for its LAN or LANs. Now in this case, it received we mentioned it received a /48. So the router can subnet. What if it had another interface, say gig 01 here? Okay, then it would be the same prefix, the first 48 bits, and then can make a subnet 2 here. So let's say we have another switch here. Send out a different RA message, but instead of a 1, it would be a 2, and these devices would be on a different subnet. Now I mentioned at home, I don't get a /48, I get a /64 from Comcast, okay, which is fine. I'm happy that I get IPv6. So it would be this plus another hextet, let's say, you know, just a 1 here. Okay, so what I get is just this entire prefix. This is what it sends me. So I can't subnet, but that's okay. My router sends out this router advertisement, what we see here, and my devices use Slack to create their own IPv6 addresses. So I have a globally routable address from home, IPv6. Very cool. Very cool. All right, so that discusses gives a little information about DHCPv6 prefix delegation.